Nee, gaan nie daar vat nie. Welcome to the class, Datu. Are you well? There's your mic. Can you actually hear me?
Yes, sir.
Okay, just want to make sure if Bianca is going to join us today. What are we doing?
I just started with trigonometry this week, and I'm doing reduction formula. Yes, sir.
Okay. We'll start in a minute or two.
Yes, sir.
Okay, welcome to the class, Bianca. Okay, let's start. Bianca, what are you busy with?
So I am still busy with my task from last week.
Oh, okay. We are apparently starting with trigonometry.
Okay.
Okay, and so let's just make a new section there. Great. Reduction values. Okay, trigonometry in grade 11 is actually a huge upgrade from grade 10. It's going to be slightly harder. There's a lot more that you need to know. Now, this section that we're going to start with now, you have to give careful attention to. It can be quite daunting. But once you understand it, then you should be fine. There's a lot of marks in this. This is called reduction values or just reductions. Basically, it boils down to the following. You're taking an angle that is larger than 90 degrees and you're reducing it to either 60 degrees, 30 degrees, 45 degrees, 90 degrees, or 0 degrees. Why would we want to do that? Anyone?
Because I think it's because it's an acute angle.
Yes, but those are specific acute angles that you have triangles for.
Yes, sir.
You have a 60, 30 degree triangle, 1, 2, root 3. Then you have 45. These angles you have to triangles you have to write down. root 2. And then there's also a third triangle. I don't know if you know this one. It doesn't exist. It's 90, 90, 0 degrees, 0, 1, 1. That triangle is going to disappear once you do trig graphs. Once you've done the graphs, then you don't need that triangle anymore. So I want you to quickly to write down those 3 triangles. Copy them. Give me 1 second, I'll back. Just was I muted now?
Yes, sir, I couldn't hear.
And no one helped me.
I didn't think that you were talking.
Oh, shucks. Tatu?
No, sir, I couldn't hear you.
Okay, let's just redo this. Flip. Okay, let's start off with a system of axes. Now, in trigonometry, we start here at 0 degrees and we move anti-clockwise is positive. So if I move 90 degrees on, I get to 90. If I move another 90 degrees, I get to 180 degrees. Moving on another 90 will get me to 270, and obviously moving another 90 degrees will get me to 360 or back to 0 again. So it's 360 degrees and 0 degrees is exactly at the same point. But that if you draw a sine graph, for instance, you'll find out that if you start the graph ends at 360 and you're back at the same spot basically. Okay, this is called quadrant 1, and it's A for all ratios are positive. This is quadrant 2, and this is called S for all ratios, only ratios of sin is positive. This is quadrant 3, and it's called T, so it belongs to tan. So only tan is positive, and everyone else, sin and cos, is negative. And this is quadrant 4, and this is C for cos. So only cos is positive in the quadrant any degree between 270 and 360. In other words, if I do cos of 120 degrees, then I know it's in the second quadrant. 120 is between 90 and 180, and that will give me a negative cos value. If I do tan of 300 degrees, that is in the fourth quadrant. Can you all see that?
Yes, sir.
That will be negative tan ratio. And if I do sin 150, that's in the second quadrant, and that will be a positive value for sin. Basically, that's what we use the system of axis for. Right. You're going to, obviously negative is then clockwise or this way. You are going to quickly dot this thing down or write it down if you don't have it yet. Quickly write that down, and then I'm going to show you how to do the reductions.
Okay.
You can tell me when you are finished. We are going to add stuff to that, but we are only going to work with the basics now.
I'm done, sir.
Okay. Tatu?
Almost done. Yes, I'm done.
Right. So now they're going to ask you to do the following without a calculator. So they're going to say simplify without a calculator. Then they're going to say cos 120 degrees. So you're going to look at your system of axis. Just going to redraw it there. And I'm going to say, look, I can break up 120 degrees into either 180, 360, 0, 90, or 270. But for now, we're going to just disregard 90 and 270. There's one rule that I have to teach you before you can use that. And I'm going to mix it up with one of those angles I've got in a special triangle. So either a 30, a 60, a 90, a 0, or a 45 degree. So I will break up cos 120 into cos 180 minus 60. Because 180 minus 60 is 120. Then I'm going to ask, in which quadrant is 180 minus 60? Or you can ask, in which quadrant is 120? It's the same question, basically. And you'll find it's in the second quadrant. Is that correct?
Yes, sir.
That means my cos answer or ratio will be negative. Now I'm going to try and explain it so that you understand. Okay, so it's negative cos 60. Okay, the reason I'm doing that, I can just disregard the 180 because if I take the 60 degree angle in the first quadrant, 1, 2, root 3, I can also flip it over to the second quadrant, like congruent triangle in the second quadrant. And then I can use any one of those. So in other words, the question was 120 degrees. So the question was the triangle in the second quadrant. But I can disregard that triangle and just use the first quadrant answer as long as I got the sign, which is negative cos in front of it. Look, because this is going to be cos -1, because this one value becomes a -1. So if I use that triangle in the second quadrant, it is -1 divided by 2. I'm just going to rewrite this. This is scrambled. So I'm going to disregard this triangle. I'm just going to use the first triangle by getting the sign of cos right. The sign of cos is negative. So it's a negative cos, and then I can just use the triangle in the first quadrant, which is 60 degrees. And that will give me negative. And then I have to write down this triangle to show that I didn't use my calculator. So I'm not going to do this again. I'm not going to rewrite the triangle in a different quadrant. I'm just going to get the sign of that specific quadrant for cos, and then I'm just going to use that normal triangle. So that's negative cos 60, which is -1/2. Do you understand this? Let's do another one.
Yes, sir.
Yes.
So for instance, I had tan 150 degrees. I'm going to say, look, that's the same as tan 180 minus 30. And that's second quadrant. So that will be a negative answer for tan, and I can just use a normal triangle then. Tan is opposite over adjacent. So that's negative tan 30, and that will equal negative opposite, which is 1/√3. So reductions just means I'm taking that big angle and I'm reducing it to one of the smaller angles that I actually know how to work with. So let's make the sums bigger. So say for instance, I have sin of 480 degrees times cos of -60 degrees. Now what's nice, say for instance, I have a 30 degrees here. I can add 360 degrees whenever I want to. It just brings me back to exactly the same spot. So sin of 30, for instance, would be exactly the same as sin of 30 more, or added 360, which is 390. Those are exactly the same, because I can just deduct 360 or add it, which is just like, what do we call it? Just one period, basically, of that sin. So I'm adding just, it's called omwenteling. It's just, what's that in English? Where you just go around and back to the same place.
A revolution.
That's just a revolution. I can also deduct it if I want to. I can deduct 360 degrees and I get back at exactly the same spot. So what I'm going to do with that 480, which is way too big to work with, I'm going to take 480 degrees and I'm going to subtract 360. So that's the same as the sin 120. Now, very important. Let's go back to that system of axis. Minus 60 degrees is the same as 0 degrees minus 60 degrees. So I can start at 0 degrees and subtract this way, 60. And that will give me the quadrant that I'm working in. And that quadrant is the fourth one, which belongs to cos, which means that's going to be positive cos 60. Right? So now I can work with the sin 120. Sin 120 is the same as 180 minus 60 times cos of 60. That is in the second quadrant. So it's positive for sin, positive sin 60 times positive cos 60. And now I have to draw my special triangle, 60, 30 degree, 1, 2√3. So now sin of 60 is opposite over hypotenuse times cos of 60 is adjacent over hypotenuse. Then I get √3/4. That isn't too difficult. Would you be able to do that?
Yes, sir.
Okay, cool.
Yes, sir.
One more thing, and then we're going to do simple examples, and then I'm going to show you how to work with 90 and 270. I can also have tan square of, let's say, 240 No, let's make it a negative angle of 330 times sin of 150. So that I can rewrite that as the square of tan 330 times sin of 180 minus 30. Do you agree?
Yes.
Yes, sir.
Good. So 330 is the same as 360 minus 30. And that is second quadrant. So it's positive sin 30. Right, let's work with this tan. It's the square of fourth quadrant. 360 minus 30 is the fourth quadrant. So that will be negative for tan 30 times sin 30. Now I only have to draw this one triangle because I only have one angle here. 1, 2, root 3. Now I have negative, okay, tan 30 is 1 over root 3 squared. Sin 30 is opposite over hypotenuse. That's a half. Minus root 3 squared is a third times a half. And then it's what? 1/6. Okay, so that's not too difficult. Now, there's another way that they can ask these sums. They can do this. They can say, work out the following or simplify the following. Sin of 180 plus alpha, for instance, times, or x, or beta, or theta, or whatever. They like using alpha. In algebra, we like using x, y, and z for unknowns. In trig, we like using theta, alpha, and beta. But they can use x, y, and z as well. So let's use theta for now. So they can ask you, what is sin of 180 plus theta times cos of what? Minus theta divided by tan of 180 minus theta. Okay, there's some other things that you don't know yet, but we'll get there. Now, theta just represents an acute angle. So 180 plus theta is going to get me in the third quadrant. That's tan's quadrant. So that's negative sin of that acute angle, theta, which I don't know, times negative theta is 0 minus negative theta, or 0 minus theta. So that's fourth quadrant, 0 minus theta. And that's positive cos. And at the bottom, I have 180 minus theta. That's second quadrant. So that's negative tan theta. Okay. Now these two negatives just cancel one another. Negative divided by a negative is positive. And then you have to learn the following, that tan can be rewritten as sin divided by cos. Look, it doesn't have to be theta. It can be any unknown. So basically I have sin theta times cos theta divided by sin theta over cos theta. You can do that calculation quickly. It's cos square theta. I multiplied, there's two ways of doing it. You can multiply it with the common denominator, which is cos over cos. Then this cos and that one cancels. And that cos becomes cos square. That sin and that sin cancels. So it's cos square theta. Or you can do it classic way and say that is the same as sin theta times cos theta. If I divide with sin over cos, I multiply with the inverse, which is cos theta over sin theta. To divide with a half is the same as multiply with 2. or divide with 3/4 is the same as multiplying with 4/3. So I just flip that over, and then that cos, sorry, that sin and that sin cancels. So I get cos square theta. That's called an identity. And there's two that you have to learn in grade 11. Do you want to dot this down?
Yes, sir.
Yes, sir.
So you don't have to do the red route. You can just go the normal route if you want to.
Okay.
Then we're going to play around with a couple of examples. And I have to show you what is co-functions as well. Two things. Tell me when you are finished.
Done, sir.
Okay, good. Right, let's just look at two examples again before we continue. So for instance, I have sin of 240 times cos of 150 divided by, let's make that cos square, divided by tan of, let's say, minus 150 degrees. Right, let's do that. So the 240 is the same as 180 plus 60. That's just the square of cos. You're going to skip this step soon. You're going to just say that is third quadrant and there's a 60 difference. So it's minus sin 60. But let's just not do that yet. This is quite new. Just going to move this slightly. So that's the same as cos 180 minus 30. And minus 150, I don't know what that is. Yes, I'm listening. What would you do there with a minus 150? It's there. Minus 150. I'm just going to add 360. No, I can whenever I want to add or subtract 360. So I'm going to do minus 150 plus 360 in my calculator. That's the same as tan 210. Right. Third quadrant, negative sin 60 times squared. Second quadrant, negative cos 30. Tan 210 is the same as tan 180 minus, no, plus 30. It's not a nice sum, this. Then I need this triangle again. We haven't used 45 degrees now. That's a pity. So minus sin 60 is minus, and sin of 60 is root 3 over 2 times squared minus cos 30 is also root 3 over 2. And then that is third quadrant, so it's positive tan 30. So on top, I have negative root 3 over 2 times, well, root 3 over 2 squared is 3 over 4. And the bottom, I have tan 30, which is opposite over adjacent. And that's 1 over root 3. Okay, now it's just a little bit of fractions there. So I've got negative 3 root 3 on top with the 8 at the bottom. And that's going to be divided by 1 over root 3, which is the same as multiply by 3 over root 3 over 1. See that?
Yes, sir.
So I just multiplied with a flip. Flip the fraction over, multiplied. So now at the bottom, I have 1 times 8. And the top, I have minus 3 times root 3 is 3. And minus 3 times 3 is minus 9. Good. Write that one down. That's a good example of what you should be able to do. Then we're going to do co-functions. And then we're going to do proper examples. Good. Tell me when you're
Yes, sir.
finished. Okay, good. Now,
I'm not done, sir.
okay, right, fair enough.
Done, sir.
All right. Now, we've only done the following. We've only worked with 0 or 360 minus, not really plus, because there's no need, because then you'll have a acute angle anyway. And we've only worked with 180 minus or plus. Now, there's also 90 and 270. You can work with 90 plus or 90 minus, or 270 minus or 270 plus. Now, once you work with those, or the minute you work with 90, in other words, 90 plus minus, or 270 plus minus, these are called co-functions. Sin then becomes cos, and cos becomes sin. So, for instance, let's go back to sin 120. We did it this way. We said that's the same as sin of 180 minus 60 degrees. And that will be second quadrant. So it would be positive sin 60. And then we read that from the triangle and we got root 3 over 2. But you could also have done it this way. I don't recommend it. But sometimes you are forced to use co-functions. You can also say that's the same as sin of 90 plus 30. 90 plus 30 is in the second quadrant, so sin is positive. So listen carefully. First, get your sign. That's the positive or the negative sign. So 90 plus 30 is second quadrant, so it's positive, but sin becomes cos. because we are working with 90 plus minus. And that's cos 30. And then you use your special triangle to read off cos 30, and then it's root 3 over 2. Okay, so when will we be forced to use that? Let's do example where we are forced. So let's do sin of 140 degrees times tan of 45 degrees divided by, let's say, cos of 50 degrees. Okay, now you can immediately see we have like big problems. Because if I take that 140 and say, okay, fine, that's the same as sin of 180 minus 40, I have a problem. I don't have a 40 degree somewhere in a triangle. That means I can't work it out. I can't calculate it without a calculator. So it will have to cancel. Tan of 45 is easy. It's already acute angle. I only have to draw my 45 degree angle, 1 root 2. Tan of 45 is 1. And that is just already acute, 50 degrees. But I don't have a triangle with 50 degrees in. So the sin and the cos will have to cancel. On the top, I have the second quadrant. So it's positive sin 40 times 1, which is going to be sin 40. At the bottom, I have cos 50. But now I can actually transform them. I can leave the sin 40 at the top if I want to, and I can say cos 50 is the same as cos of 90 minus 40. That's 50 degrees. That's in the first quadrant. Everything is positive in the first quadrant. So cos is positive. But cos becomes sin because I'm using 90 degrees. So I've got a sin 40 at the bottom and I have a sin 40 at the top. And that answer is just 1. So I'm going to be using co-functions if I'm forced to do it. Not because I want to, but because I'm forced. Write that down. You're eating an apple, Tatu.
So,
What are you eating?
not eating anything.
Tell me when you are finished.
Done.
Yes, sir.
Right, let's do another example with the co-function. Let's say we have sin of 90 minus theta times cos of, let's say, 270 minus theta. Divided by cos of 240 degrees. Right, let's go. Sin 90 minus theta is in the first quadrant. Everything is positive there. So sin becomes cos because we're doing co-functions. So that's right. 270 minus an acute angle gets me to the third quadrant. Cos is negative in the third quadrant, but cos becomes sin because we're using either 90 or 270. So that's negative sin theta. And cos 240 is the same as cos of what? 180 plus 60. So on top, I have negative cos theta times sin theta. And at the bottom, I have the third quadrant, which is negative cos 60. So negative cos theta times sin theta over negative cos 60 is half. A negative divided by a negative is positive. If I take the half up, it comes to, that is 2 cos theta times sin theta. And in grade 12, not now, you will learn that that is sin 2 theta, but you don't have to know that now. You can only do right up to that. Okay, now what I'm going to do, we're going to spend some time doing examples. Unless you have questions for me.
No,
Oh,
sir.
let's just look at, before we start with examples, let's just look at our two identities. You have to know the following. Tan can be converted into, not cos over sin, sin over cos. And also, the other identity is that sin square x plus cos square x is 1. In other words, sin square x is 1 minus cos square x, or cos square x is 1 minus sin square x. Write that down because you might need that in one or two examples, especially the first one. The tan can be converted into sin over cos.
Thanks, sir.
Right, cool. Okay. Let me get those examples. Okay, give me a second to copy some stuff here. Maybe I can print it into the screen actually. There we go. No, you can't see this. Right, can you actually see this?
Yes, sir.
Okay, you might want to take a screenshot of that. Okay. This is all your co-functions written down. And that's your two identities. It's not necessary. You've got all of them, but maybe you just want to do a screenshot there of that. Right, let's start. Let's do that first one. Not we, you. I'm just going to copy it and paste it on another page so we can actually work on it. There we go. Okay. You have 3 minutes.
So
Yes.
we're not working on identity, we're just working on the reduction. Right?
Yeah, this reductions. But I'm just showing you those two identities because you can actually, they can incorporate it into these reductions if they want to as well.
So
This one doesn't have an identity in. But sometimes they just put the tan in where you can change it to sin over cos and then you can cancel a cos or something. You get a better, a more simplified answer basically. I'll get you one now. I'll show you now what I meant. But this one, you don't have to worry about that. If you don't know how to do it, it's fine. It's your first round, so it's you'll find there's some angles there that you can't solve. You can't get them in a triangle, and they will cancel one another. So the sin 20 and the cos 70 will actually just cancel one another in a way.
Okay.
Oh, yes. Sir,
Yes.
can I please ask if the answer like sine 30, because shouldn't the cos 0 and the sine 90 cancel out each other?
Yes. Where's your sine 90? Oh, okay, I see it.
Yes, sir.
So the answer is going to be minus half.
Isn't it, sir, since they're the numerator and the denominator is gonna be like a thing, a negative, so shouldn't the negative
yeah.
sign cancel out each other? Therefore, it is.
Hey, you're on the ball, Tatu. You know exactly what you're doing here.
Yes, sir.
Okay, I'm just going to show you exactly how to do it.
Okay.
So that sin 330 is the same as sin of 360 minus 30 now. Is that right?
Yes, sir.
Bianca?
And sine 20.
Yes, sir.
The sine 20 I'm going to leave.
Yes, sir.
The cos 0 I'm going to leave. The sin 270, you could do it various ways. You could have written sin of 180 plus 90 if you wanted to. But I'm not going to do that. I'm just going to write sin. You can do 360 minus 90. Or you can just do 270 plus 0. Doesn't matter. I'll show you the other way just now. And then the cos 70, I'm going to change as cos of 90 minus 20 to get 20 degrees into the sum. Yes. So that's fourth quadrant. Negative sin 30 times sin 20 times. Okay, cos 0 I can do because I have this triangle. 90, 90, 0, 1, 1, 2, 0. So cos of 0 is 1. Or you could have thought of the cos graph. There's a cos graph. Cos of 0 is 1. Then this is fourth quadrant. Negative for sin, but sin changes to cos 0. Times, this is first quadrant, so everything is positive, becomes sin 20. Now, these two cancel. You could have left the cos 0 as cos 0, and then the cos 0 and the 1 will cancel. Because cos 0 you just worked out as 1, that will cancel. And a negative divided by a negative is a positive. So I'll get positive sin 30. and this is a half, but I have to draw that triangle too. And that's 30 degrees. 1, 2, √3. Sorry, this pen is a bit thick. Excellent. If you're not good at this yet, it is actually fine. Let's find another one. I'm looking for x's and something that I can hopefully change. Yeah, okay, this is not a like a sum. Let's do 8. No, let's do 7. 9. 9. 9.
9.
Yeah, why not?
Oh, I'll just,
Do you want to do another one?
no, sir. I'll just.
I can send you this document with a memo.
Yes, sir. Please do.
Right, okay, there you go. While you're doing this, I'm going to send you this whole document with a memo.
Okay.
Just excuse me. Sorry about that.
No problem, sir.
Managing?
Yes, sir.
Yes, sir.
No triangles needed. Easy peasy.
No, no triangles needed.
All right, let's start. Are you happy? Or not yet?
Not yet, sir.
Okay. Take another minute. It's fine if you can't.
So X D multiply. Sir,
Yes.
is it possible if my answer can be sine x divided by cos x squared?
I doubt it, but it's possible. Let's run through them. Like, okay, let's go. Fourth quadrant, negative sine x
Yes, sir.
times second quadrant, negative tan x. Now, times negative, I'm just going to fix that. That is x minus 90. That's quite difficult, okay? So x represents an acute angle. If I subtract 90 degrees, I go to the fourth quadrant. And that means what? Negative for sine, but sine
Yes, sir.
becomes cos. You see that? So that's cos x. And this is first quadrant, everything is positive, so that becomes sin x. So Oops. So that sin and sin cancels. That negative and that negative is a positive. So what remains is tan x times a negative is cos x. But tan is the same as sin over cos times cos x over 1. And those two cancel. And then I get sin x. Bang. This will take some practice. That's why I'm sending you that sheet so that you have a full memo, see what all the steps, and you can practice that. This part in your trigonometry, there's a lot of marks. This is like 5 or 6 marks, just this little sum. Because you get a mark for all your conversions. There, that one, that one, that one. You get a mark for this using tan, converting into sin over cos, and you get a mark for the answer. So that's 6 marks. That's a lot of marks.
Yes, sir.
Good. Next week, we'll be looking at identities and general solutions, maybe. The trigonometry is a huge chapter. It's very important. Okay.
Yes, sir.
Don't do any trig graphs now. Have we done trig graphs? No.
Yes, sir.
Have we? That's a pity. Because the trig graphs like like moves into this, not this section, but one of the other sections we're going to do. Okay, so we've done trig graphs. Okay, good. I'll see you next week.
Right, sir.
Do I have your test dates? I think so.
No, sir.
I'm not sure. I think I do. We are working towards completing the syllabus before you're writing the test, eh?
Yes, sir.
And you're doing some other tutorial for when? For Tuesday or for what? When must that tutorial be in?
Monday, because I'm writing Tuesday, sir.
Okay, but you've done it. That's true. We
Yes,
looked
sir.
at it. Did you see the video, Bianca?
So I wanted to ask you, like, where must I go?
Oh, okay. Let me just go. Let me just quickly show you. I'm just going to interrupt. The video, I'm just going to share the screen quickly with you guys.
Okay.
You share. Just give me a second. So the channel name is Viscous Kainat. Okay, let me share the screen quickly. Is it this one? Can you actually see a screen there? Different one.
Yes, I can.
Okay, it's, can you see this Viscous Kainat, this name here?
Yes, I can.
Okay, so you probably need to go to, I don't know, show more. Oh, there's a drop-down menu of all the different playlists. And you're looking at, yeah, HS means homeschool grade 11 math.
Yes, sir.
Yeah.
You click on that, there will be, okay, there's only 3 videos at the moment. I don't know where's that other video? There's a video missing there. Anyway, if you have problems finding something, I can always send you the link.
Okay.
I think
thank
I've
you.
messed up this channel. Maybe I've put some of your videos under the Afrikaans one. No, I don't know. Maybe I put it under the normal grade 11 maths. Because there's a lot of videos there. But if you're looking for a video or something that we've done here,
Yes.
then you could just, I'll send you the link.
Thank you, sir.
All right. I'll send you the link on that video we made on this.
Okay.
Okay. Keep well.
Guys, keep
All right.
well,
You
sir.
too, sir. Bye.